Hey guys, welcome back to Now I Know. Today we are talking about normality. We are going to see in this video how to do different types of normality calculation. Now, even before I start with the video, honestly I'm going to tell you guys that normality calculation used to be one of the calculations that used to scare me like anything, because I did not have a clear concept about how to do the calculation, so I couldn't do it properly, and if I see normality calculation I will run in the opposite direction as far as I can. But now that I have understood, I have decided to share this technique with you, the formula that is used to calculate the normality calculation. I'm sure after this video it would help you to do many different types of normality calculation. So let's begin today's video. So to understand normality, let's recall one of the calculation that we had talked about before, and that is molarity. In one of the previous video we were talking about molarity, and we know that molarity is nothing but just a way to express the concentration of a solution, right? Similarly, normality is also a different way to express the concentration of a solution. There are different ways that we can express the concentration of a solution. Molarity and normality is one of them. And I'm talking about molarity because there are similarities when it comes to molarity and normality. There is a relationship between molarity and normality that we need to understand. Now for molarity we were taking moles in consideration, right? Moles of a compound in a liter used to give us the molarity. For that, of course, we were taking molecular weight in consideration. Similarly, normality takes equivalence in consideration. I'm just showing you, the difference between molarity and normality. Once I will put the normality in formula form and explain you what that means, that is more than enough that you need to know to do different types of normality calculation. And what this means is, along with the molar mass of a compound, normality also takes in consideration the valency of a compound. It is very, very important, right? Valency as in how many protons or OH minus ion, or if you're working with a solution containing sodium, then you have to take in consideration sodium ion. Say for example, I'm talking about H2SO4. On dissociation, I'm going to get 2 proton plus, right? So this is the valency of H2SO4, 2. And the same thing is also called N factor. Alright, so this much is clear so far, that normality along with molecular mass also takes valency in consideration. That's what we also going to call as N factor. Why it is important, just in a while you will see. So let me now put this thing in a formula, right? We have understood this. Now let me show you how to express it in formula that we can use it. So as I said, normality takes equivalence in consideration, right? So normality is equal to number of equivalence, of course, of a solute, because we are talking about any compound. So number of equivalence of solute per liter of a solution. Now volume of a solution in liter I understand, okay? It is as simple as that. It is the volume that we are going to prepare. Say for example, I'm preparing 2 liter of a solution, 500 ml of a solution. Whatever amount that I'm going to prepare is going to be over here. But what is this equivalent of a solute? How am I going to express this? Number of equivalence would be the weight of a solute. We will take weight of a solute divided by gram equivalent weight. Do not get, do not get tense seeing all these big terms. Once I'll explain you, put it in formula, believe me, it's going to be really easy. But just understand this as of now. Number of equivalence of a solute can be obtained when you take weight of a solute and divide this by gram equivalent weight. Okay. Now what is this weight of a solute? Weight of a solute would be, say for example, if I'm doing some problem and they have said you have to take some X gram and dissolve in some Y ml, that amount that they have given is my weight of a solute. What gram or what amount of my compound I'm going to dissolve is my weight. Now sometimes this will be unknown to us. In some protocol, if you're following an experiment in lab, they would ask you prepare 0.5 normal some solution, right? In that case, you don't know what amount, how much should I take that compound, right? That is the weight of solute that we need to calculate. So sometimes it will be given, sometimes we have to find this. Alright, so this is clear, volume is clear, weight is clear. What is this gram equivalent now? Gram equivalent weight is what we just saw over here, right? The molecular weight and valency. That is when you take the molecular mass of a compound and divide that by the valency of that compound. We just saw the example of H2SO4. So H2SO4 molecular weight is 98 and valency is 2, right? So 98 divided by 2 would give me 49. So 49 is my gram equivalent weight for H2SO4. Alright, gram equivalent weight is when you take molecular mass of a compound, divide that by the valency, you would get gram equivalent weight. So now I have, I took this number of equivalent weights of solute, I simplified it and I got two different steps over here. Let's try to put all these together, because once we put all this together, we get the key formula of normality. So let's see how to do that. So see, this is what I got. Normality equals to, we were talking about equivalence of solute. Instead of that, we have weight of solute. Okay, weight of solute divided by gram equivalent weight, that is equal to molecular mass by valency. So whole of this first step is replaced by these two. Okay, so what I get is normality is equal to weight of solute. Okay, divide this by molecular mass or molecular weight by valency, and this whole thing is divided by volume of a solution in liter. It looks big, but once you remember this, once you understand this, this one formula is going to be the key formula for different types of normality calculation. So this is how I remember. Normality is equal to weight of solute. This will be either given or it will be like unknown. We have to find it out. So it will be the weight of solute. Initial amount is the quantity that either is given or to find out, divided by molecular mass and valency. This we will always know, right? Because we know what compound we are working with always. So we would have these two value always, molecular mass by valency. This whole thing is divided by the volume, right? So the first thing is some amount and the last thing is also some amount, and in between we have the molecular mass by valency ratio or gram equivalent weight. As we will see some example, I'm sure you will remember this formula by heart. You know, this is easy, not that difficult to remember. Now along with this, I also want to show you one more equation. Okay, let me say this equation as equation A. Now the second equation is a small equation which shows a relationship between normality and molarity, and that is normality n equals small n, that is n factor, into m, that is molarity. This is also one of the very important equation that you should know. Now there is a way to derive this, we are not going to talk about it, but we need to remember that normality equals to n factor into molarity. And why is this important? Because sometimes you might have solution that has given the normality and you want to know the molarity of that solution, or the solution has concentration in molar and you want to know the normality of that solution. So that is why it is important to know this equation. It is simple. Normality equals n factor into m, and n factor, again as I said, number of H plus ion or OH minus ion or sodium ion, whatever compound that we are talking about. So now that we know both the basic equation to do multiple different types of normality calculation, now let's move on and see different types of calculations. So as I said, you need to remember these two equations. This I said normality equation as A, and let's put this normality molarity relation as B. So these two equations you need to remember, and let's begin. The first problem says, what is the normality of 2 molar NaOH solution? What I have molarity. I know what compound it is, but I don't know the normality. So I can simply take this formula, n is equal to n factor into m. We have to find out the normality. So normality is equal to n. What would be the n factor for NaOH? N factor would be 1, right? So I will have 1 n factor into m. M is given as 2. So the normality of this solution would be 2. 2 normal NaOH. This problem says, what is the molarity of 6 normal H2SO4? Here molarity we have to find out, normality is given. Again we can use the same formula, n is equal to n factor into m. Normality is given, that is 6, right? Equals to n factor. What would be the n factor for H2SO4? It would be 2, right? So I will put 2 over here into m because molarity is what we want to find out. Therefore, molarity is equal to, this 2 would go over here, so 6 divided by 2. Therefore, molarity is 3. So this is how this equation is going to help you. Now let's move on to more of a preparation kind of calculation that we need to do in lab almost every single day. So let's take our main formula in use and see how we can use that. Alright, so this problem says prepare 2 liters of 0.150 normal aluminum chloride solution. This is how generally in protocols it is given, right? We have to prepare some normal solution in some quantity, but we don't know what amount of that compound we need to take. So how we will do this? For this we are going to use our main normality formula that I showed you before, which was normality equals to, I told you the quantity comes first, the grams of a solute that you need to take divided by the molecular weight of that compound by the valency, and this whole thing was divided by the volume of a solution, which was in liter, right? Okay, this much you remember, so it's easy. We are given the normality. We know the normality that we are aiming is 0.150. So let's put that here. Grams is what we want to find out, right? We don't know how many grams we need to take. So grams is unknown for us. So let's put it as x, unknown x. Divide this by the molecular weight and valency. So the molecular weight of aluminum chloride is 133.33. You can calculate this, or you can look into the information sheet comes with the chemical that would provide the molecular weight. So and the valency of aluminum chloride would be 3, isn't it? So let's put these values over in the formula, and this whole step is divided by the volume in liter. So what is the volume given to us? 2 liters. It is in liter, so we don't have to do any conversion, simply put 2 over here. Now x is what we want to find out, right? So therefore you can simplify this if you want here. Let me just do it. I simplify this. This is the value that I get. So therefore I want to find out the x. X equals to, I have told you before also in molarity video, I would like to go step by step because I get really confused with numbers. So the x, or I can say the weight of solute that I need, is equal to 13 point, when you multiply all this is the answer you get, 13.33 grams, right? So you need to take 13.33 grams of aluminum chloride, and when you dissolve it in 2 liter of water, you are going to get 0.150 normal solution. Alright, so take this much amount, dissolve it in 2 liters of water, you would get your desired concentration solution. This is how we are going to do the normality calculation. Let's take one more similar example but a different compound. Right, so this problem says prepare 1.5 liter of 0.4 normal calcium chloride solution. Once again the same thing, we don't know the amount of a substance we need to take, right? So we need to find out the solute. So let's take a formula. Normality equals to, now I'm going to put values directly. We don't know the amount, so weight of a solute is unknown. So I will write it as x divided by molecular weight by valency, right? Molecular weight of calcium chloride is 110.98 and the valency would be 2 over here, right? So valency is 2 and this whole thing is divided by the volume of solution that is given as 1.5 liter. Again it's in liter, so we don't need any conversion. Normality, I forgot to put normality over here. Normality is 0.4. Okay, so this would be 0.4. Now we need to find out the x. Let's do this. Therefore my x, or weight of solute that we are looking for, is, the answer would be 33.29. So I need to take 33.29 grams of calcium chloride, and if I dissolve this in 1.5 liter of water, I would get 0.4 normal solution. Alright, now let's take little different kind of a problem. This problem says what is the normality of 4.9 grams of H2SO4 in 100 ml. That means when I take 4.9 grams of H2SO4 dissolved in 100 ml, what will be the normality of that solution? So same formula we can use. Normality equals to weight of a solute. Weight of a solute is given over here, that is 4.9. So 4.9 divided by H2SO4. Once again we know H2SO4 molecular weight is 98, valency would be 2. So I will just simplify 49 and put it over here. So 49, divide this whole thing by the volume of a solution. Now look at this. I said volume of a solution would be, we are taking it in liters, right? But here in problem it is given in ml. So I will convert this in liter and I will put directly. So that becomes easier. If you put 100 ml over here, the answer would be wrong, right? So convert it in liter and put it. And to convert this ml into liter, we need to divide it by 1000. So it will be 0.1 liter. Now let's simplify this. 4.9 divided by 49 is 0.1. divided by 0.1, right? That is what is our quantity. So the normality of this solution is 1. It is one normal solution when you take 4.9 grams of H2SO4 in 100 ml solution. The normality is 1. Let's take one more similar example with a different compound now. This says what is the normality of 1.17 grams NaCl in 1 liter solution. So normality is what we want to find out. Grams is given 1.17 gram divided by molecular weight of NaCl is 58.44. The valency would be 1, so I can put directly 58.44 over here. Divide this whole by a volume of the solution, that is given as 1 liter. It is in liters, so no conversion is required. So that would equal to normality of the solution is 0.02. This was easy, right? Now let's take last two examples, and these are different kinds of examples now. Now these two last examples are kind of example where you have one type of solution which is made with one specific concentration, and from that you want to prepare your desired concentration solution. Something what we were talking about in one of the video where we were talking about stock solution dilution, right? Dilution of a stock solution to get your desired concentration. So you have one amount of solution ready. From that you want to prepare your desired concentration and your desired amount of solution. So that is what it is. What amount of 1.5 normal H2SO4 is required to prepare 500 ml of 1.2 normal H2SO4? I have 1.5 normal concentration, and from that I want to prepare 1.2 normal concentration, and the amount is 500 ml. So if you remember, the dilution formula that we were talking about was N1V1 is equal to N2V2. In case you want to know how we derive this, we can refer to the dilution video in our lab calculation series. The N over here is normality and V stands for the volume that we need to take. N1V1, let's keep it the normality and volume of one solution, and N2V2 would be normality and volume of the other solution. So how we can utilize this? It is asking us to find out the volume. Alright, so let's assume that V1 is what we are looking for, what amount we need to take of this 1.5 normal. So 1.5 normal, put all the units so it becomes easier for us to understand, equals to N2V2. The normality that we need is 1.2 normal into V2 is 500. 500 ml is what we are looking for, right? So 500 ml. Alright, V1 is what we want to find out. So V1 is equal to normal cancel. So when you simplify this now, you get 400 ml. That is what is our unit. Okay, that's why I told you write the unit, that becomes easy to understand. So we need to take 400 ml of 1.5 normal H2SO4. Now since we have to prepare 500 ml, you will make this amount or this volume to 500 ml, make it up to 500 ml by adding distilled water. Alright, so take 400 ml plus 100 ml of distilled water. That would give you 500 ml of 1.2 normal H2SO4 solution. That is how this formula is helpful. Alright, so that's how you can prepare your desired concentration. Now here both the solutions we are talking about are in normality, right? The unit is same. What if I have a normal solution and molar solution? How can I deal with that? So let's see one last problem showing that. Alright, so this problem says what amount of 0.5 normal phosphoric acid would be required to prepare 2.5 liters of 0.2 molar H3PO4 solution. Now I have a solution that has 0.75 normal concentration, but I want to prepare 0.2 molar solution from this. Can I do this? Yes, of course, because we know the relationship between normality and molarity. Now this is going to be easy. Since it is a dilution kind of a problem, we are going to use our formula, that is N1V1 equal to N2V2. Let's put all the value first. We want to find out the volume, so V1 is what we are looking for, say for example, and that has concentration of 0.75 normal. So let's put it here, 0.75 normal. As I said, write the units, so that way you know that if you need any conversion. N2 is the concentration of a solution that we are looking for, that is 0.2 molar. Into V2 is the volume that we need, that is 2.5 liter. Now look at this. This is in normality, this is in molarity. So what I need to do is convert either of the unit. So what I'll do is I will convert this molarity into normality, and then I will put that value over here. So we know the relation between normality and molarity is N equal to N factor into M. Normality is what I'm looking for this solution. So the N factor, since it is H3PO4, I would have N factor of 3. Molarity is 0.2. So if I convert this in normality, I get answer of 0.6. Let's put this value over here. So that would become 0.75 normal into V1 equal to, instead of this, we are going to put this value 0.6 normal into 2.5 liter. Alright, we want to find V1. So V1 equals to, normal cancels out, just simplify this. You would get answer as 2. What 2? ml or liter? Liter, because that is what our unit is in. So you need 2 liters. Okay, you need 2 liters of 0.75 normal phosphoric acid, and we need 2.5 liter, right? So you make it up to 2.5 liter. So that is how we can do different types of normality calculation. I hope this video was helpful. Do subscribe to the channel for new video every week, and I'll see you next time. Until then, keep learning.